Good morning. We're going to give everyone until about 8:35. Since today's the first day, some people trickle in late and I don't want to start and have people come after I've started. So go ahead and turn your cameras on, Hannah and Alan. Hi, Michael. And we will get started here in about 4 minutes or so.
I have a situation going on right now. Can I turn my camera after?
Yep.
Thank you.
We're going to give it one more minute and then we'll get started. Okay. Well, hello everyone. My name is Miss Olivia and I'm going to be your teacher for this class today, as well as every day if you decide to take it. I can give you a quick little introduction of who I am, and then we can do introductions of everybody else before we jump into the subject matter for today. So I am a junior at Harvard College. I study government and history. I have been working with PLE for about 3 years now. And this is actually kind of the second version of this class that I just taught for the last 10 weeks. So you're getting kind of the new but also still maybe needing to get the tweaks out, improved version of this course. The content matter is going to be a little bit different. But also the goal is for you to be able to ask questions and really engage with each other and with me and with the subject matter. That's really important. And for you to be able to take away from this class historical narratives and histories that you can use when you attend Model UN. All right, does anyone have any initial questions for me before we jump into introductions of you three? Yeah, Michael.
How will like this kind of help us with Model UN? Will it be like we'll know these like facts and we can like relate them to topics or?
Yeah, no, that's a good question. That's part of it, right? Because understanding history is really important and understanding global conditions and how countries interact with their own people and also with the larger world. And then in addition to that, I would really like you to use it as kind of a mock Model UN in the sense that, you know, I'm going to kind of experiment. We'll start with this class and we'll see how it goes, but some independent group work, and you can practice interacting with each other, and you can practice a lot of those skills that you're going to need moving into Model UN, and kind of, I mean, the rest of your academic careers as well. Those are all super useful skills. So asking questions, making sure that you understand everything, interacting with your peers, interacting with me. Those are all lots of important kind of foundational tools that you can also use at Model UN as well, that I'm going to encourage you to explore and, you know, play around with during this course. Does that answer your question? Anyone else have any initial questions before we jump into introductions of you? Hi, Annie. Okay, so we are going to get started. And what you're going to do is just tell us your name, your grade, where you're zooming in from, and your interest in taking this course. Or if you took the previous course with me too, let me and your fellow classmates know that too. Alrighty, we're gonna start with Michael.
Well, obviously my name is Michael, and I'm in 7th grade, and I'm zooming in from Massachusetts, Lexington, Massachusetts.
Excellent. Alan.
My name is Alan. I'm in 7th grade and I am zooming from Princeton, New Jersey.
Very good. Hannah.
Hi, my name is Hannah and I'm in 7th grade and I'm zooming in from Ottawa, Canada.
Excellent. And finally, Annie.
Hi, my name is Annie, and I'm zooming in from Short Hills, New Jersey, and I'm in 7th grade.
Awesome. Excellent. Okay. So as kind of a intro, I think it'll be helpful if we run through the syllabus really quick and I kind of explain to you what the heck the plan is. So syllabus is on the Google Classroom. So once you get access to the Google Classroom, you can see this. It might change a little bit. So if there's an update, I'll go ahead and just update this. But this is the plan for now. So today, we're talking about the scientific revolution. And part of the goal of this is to give you kind of a broader historical lens to start thinking about some of these ideas. As we move through the weeks, we're going to be seeing a lot of, actually we'll probably move the Enlightenment up. So we'll probably talk about the Enlightenment next week. So see, already he's making some tweaks. But the scientific revolution is a really important kind of multi-step process that happened and is in some ways still happening today, that kind of changed the course of history, right? Like without the scientific revolution, we wouldn't have vaccines, for example. We wouldn't have nuclear bombs, and those things affect global politics a lot right now in particular, right? Does that make sense? So kind of thinking about how history has changed over time, how these concepts have kind of permeated and are omnipresent throughout time, and how we handle these sort of conversations and situations today via the lens of history. So that's kind of the goal. Now, if at any point you're like, I have no idea what is going on, please just raise your hand. It's important that you are all kind of active and participating and able to let me know that you need maybe a little bit of assistance in explaining something better or explaining something differently. So just keep me in the loop in terms of where you're at, understanding wise. Second order of business is not every week, but some weeks you might have homework, and you can find those in the Google Classroom. Okay, so just check the Google Classroom. I'll post announcements in there, send you some reminders, and sometimes you might have a worksheet or two to complete for homework that you might have to present during the next class. So it's just important that you just check the Google Classroom once a week. And I'll tell you if you've got homework, but just so that way you're not missing any announcements or anything like that. Whew. Joy, can you turn your camera on and tell us your name, your grade, and where you're zooming in from? Alrighty, so we are going to also kind of discuss some of the expectations for you all in terms of participation and engagement and what you can expect from each of the classes. So the way that I generally operate my courses is splitting up time between group work and videos and instruction time. So today we are going to start with a PowerPoint. I'm going to present it, and then we're going to split up and you guys are going to work on a worksheet together, and then we're going to come back to the big group and you will present your findings, and we'll just go through each of the questions, and someone from the full group will just answer those questions one by one as we go. I find it really important to participate. Even if you're shy, it's okay. Please just raise your hand and participate. Keeping in mind that you do get a report card at the end, and you want your participation points to be 100%, because they're really easy to get. Also, the videos that I show you are going to primarily be crash course videos. So if you're familiar with crash course, you'll know that they go by kind of quick. That's okay. Just make sure that you're paying close attention. So don't leave your computer if I'm turning the video on. Sit there, pay attention, and then we'll do kind of any questions about the video after we show it. We'll have a practice run of that today. I have a video to show you on the scientific revolution. And as always, if during kind of a lecture or a video or group work or what have you, if you have any questions, you can always send me a chat, raise your hand, call me into a room, ask me questions. That's 100% welcome and encouraged. Okay? So, one final note before we jump into the classroom, before we jump into the content for today. When you are split up into groups, it is very, very important that you actually talk to each other to get the group work done. And I can see if you're talking to each other or not because the host has little microphone symbols next to each person. So I will 100% know if you're sitting in the little breakout room, not chatting with each other at all. So just making sure that we're actually participating, that we're actually chatting, and that you're getting the most out of the class that you can. Okay? Thumbs up if that sounds good. Show me those thumbs. Awesome. Hi, Daniel. Can you go ahead and turn your camera on?
Yes, no problem.
Thank you. Okay, so today we are talking about the scientific revolution. Now, the scientific revolution happened over the course of a couple of centuries, but the one I want to talk about today is going to be kind of all of that, right? I want to talk about from 1550 to about 1800. And this is when we get Copernicus, this is when we get Galileo, this is when we get the idea that the Earth revolves around the sun rather than the sun and all of the other planets revolving around the Earth. So we move from a geocentric to a heliocentric solar system. So lots of fun stuff today. Give me just a second. Slideshow. Okay. So the way that we view the world and the way that we understand the world around us is largely based on observation, right? We look into the sky and we see stars, or the moon, or the sun. And the tracking of these things, the tracking of the Earth's movement, or of moon shapes, or of star patterns, were all very, very interesting to people back in 1550. Keeping in mind that they were trying to survive famines and diseases and lots of other things. So their lives were kind of chaotic. So probably stargazing was a bit of a cathartic release to their very chaotic lives. And what this did was it introduced a whole host of ideas about the solar system and the world and life as we know it. Now, most of them were wrong about everything, right? They have a very different kind of mindset when thinking about how the world works. These scientists and observers were very religious, so a lot of their understanding of the world came from religious texts. And they were largely unfamiliar with just how big the world was, right? That's why Columbus, when he thought he hit India, had actually hit a whole new continent. They haven't really explored everywhere, and it's hard to kind of grasp how big the world is if you haven't been exposed to the world other than just your state, right? So keeping that in mind. So the point of that is that if you had no technology, if you had no Google, you had no Google Maps, you had no, world map view, and you wanted to explain why the sun comes up and the sun goes down and the moon changes shape, and sometimes we have shooting stars and northern lights and an occasional eclipse. Those things can be kind of scary if there's no understanding of what they are, right? So observers and scientists in 1550 began to come up with some hypothesis as to how the world was working and what the heck was actually going on out there. And here you can see one of the first heliocentric geocentric drawings of how people thought the solar system that we are in operated. And you can see that the Earth is in the middle. So these kind of initial observations put Earth as the center of rotation. Earth doesn't move. We would know if Earth moves because we would be flying around, right? Does that make sense? So there's no concept of gravity. There's no concept of kind of orbital experiences. And so these observers were like, well, we know that the Earth isn't moving because we're not moving. So everything else must be moving around us, right? That's kind of the initial thoughts of these first explorers. So this is what they drew. They said, okay, well, the Earth is in the middle, it's not moving. And then we've got the moon, Luna is the moon. We've got Mercury, we've got Venus, we've got the sun. And then we've got Mars, Jupiter, Saturn, and Fermento is gonna be Neptune. Okay, so they're missing some planets. No big deal. The sun is somehow in between Venus and Mars, and the moon is quite a distance away. And so then you can also see that there is air and that there is fog. So they're trying to account for the atmosphere, right? They're saying, well, there's clouds in the sky. Sometimes there's some other weather patterns. Sometimes it rains, sometimes it snows, sometimes it's sunny. And they're calling that fog. And it all exists within this little air bubble around the world, right? I mean, they're not wrong. And so this is one of the kind of first ideas about how the world works. And this got people super interested in talking about the world. And one reason why this is super important for continued understanding is because it starts to challenge the view that everything revolves around us, right? Especially when we get into heliocentric views of the solar system where the sun is in the middle, not the Earth. And when everything stops revolving around us, then religious becomes a little bit more precarious. And so these people are beginning to question their religious identities, their deities, what have you. And we end up with not only a revolution in the form of the scientific revolution, we get the Enlightenment as well, which is a more kind of focus on your personal self, whatever. Michael.
I was just wondering who invented like the idea of God or like a religion.
So it depends on which religion you're talking about and what kind of time frame you're looking at. But this idea of other
A supreme ruler.
Yeah. This idea of supreme rulers or deities or other beings existing has been around since the dawn of time. To put it lightly, it's part of the human experience to place our trust into outside sources when we can't explain why things are happening. And so when you have an eclipse, right, if you are very religious and it goes dark, like that can be really shocking. And so you have no other way of explaining that other than like God's mad at me. And so we see this even in, the Mayan and the Incan civilizations. We can see, the Egyptians have many, many gods. And so the things that they can't explain, or if they want to change something, they reach out to supreme powers. Does that make sense?
Yeah. Okay, thank you.
Any other questions about anything we've talked about so far? Awesome. Okay. So, yeah, Hannah.
I actually have a picture. Have a question about the last picture.
Yeah.
That picture, like, like the people in like thousands of years ago, like their point of view of the world, like their like the earth, the world, and their opinions.
Yeah. So this was one of the first drawings that we have of the how people back in 1550 thought the world existed. Now, what else happens in 1550 or the 1500s religiously? You guys know? When is Protestantism created? Do you know? So in 1550, in England in particular, we get a full move towards Protestantism in the Church of England. So they break away from the Catholic Church and they're like, we want our kings to be able to get divorced. Like, they keep killing people for not having male children, and so it's easier to just allow them to be divorced. And this is kind of happening right around the same time. So there's lots of transitions occurring. This happens for a number of reasons, right? When we talk about, well, why is this just now happening in 1550? Why are we just now seeing people kind of thinking about the world in this way? Like, what were they doing for the first 200,000 years of existence on this planet? Like, what was going on? And there's a couple of historical contextual points that are super important. Number one is the age of exploration. What is the age of exploration? Hannah.
An exploration.
Okay. Michael.
I think it's like the 1400s when like Christopher Columbus and a lot of European like sailors tried to like colonize the world and go to everywhere.
Yeah, absolutely, right? We have Amerigo Vespucci, we have Christopher Columbus, we've got Francis Drake, we've got the conquistadors going to the Incan and the Mayan and the Aztec civilizations and demolishing their entire civilizations. And this age of exploration is super, super important because what it does is it shows the Europeans there's a heck of a lot more world out there than they were aware of. And so they say, well, if we didn't know that 4 other continents existed, what do we know about the universe, right? Like, what do we know about like the stuff in the sky? And so they begin to be really curious about things other than just survival, because we're coming up to a point of survival being something that is almost a given, so long as you eat and you have some water and we're not being killed by wild animals as frequently or by strange diseases. We're kind of starting to understand that hygiene is important. Maybe we should take a bath and get rid of our fecal waste in a relatively hygienic manner. Water is becoming more clean, and kind of all of these changes are giving people the space and capacity to think about other things other than work or chores or survival. Does that make sense? Daniel, I think you had a hand up before. Was that a question?
No, it was accidental. Sorry.
Okay, no problem. Any questions? Okay. So, in addition to that, the age of exploration introduces a lot of new kind of needs, right? We need people to make maps. We need people to make better compasses. We need people to kind of help with the whole navigation situation so they don't end up in the wrong place, thousands of miles off track. Okay, let's kind of jump into defining first what a revolution is. So there are political, social, religious, whatever. But what is a revolution? Michael.
Is it like where new ideas or like new things are being introduced?
Okay, so new ideas are being introduced. Hannah?
I think it's something related to the government systems.
Government systems. Okay, anyone else? So new ideas, government systems. Alan?
I think it means like an overthrow of something, like previous ideas.
Okay, an overthrow of something, maybe an overthrow of previous ideas. Anybody else wish to kind of contribute to this working definition of revolution? So a revolution is a new way of thinking. It's a change in thought, a overthrow of ideas, if you will, and potentially an overthrow of government. So Hannah can also be correct in that. In particular, revolutions mean change. So it's a change in thinking about society or the world that differs from the previously held beliefs. Most of the time, and in this case, relying upon new science, experimental science, and science, which is kind of new in general, right? Relying on science at all is something that's new. So if we fast forward a couple hundred years from 1500 to 1600, we have the Renaissance. And perhaps next week we'll spend a little bit of time talking about the Renaissance and what role it played with this, but Renaissance humanists ended up mastering Greek and Latin, which was important because they were able to then read Ptolemy and Archimedes and Plato and all of these great philosophers. And the humanists disagreed with Aristotle for a couple of reasons. Aristotle was kind of high and mighty, and he preferred individual thought versus kind of total thinking. This isn't super important, but gives you some context. And as I said previously, we've got new problems, right? We're trying to travel the world and our compass isn't working properly. We have no idea where continents are. The stars are all messed up on our maps. Like, we have new problems that then require new solutions. And so how do you get new solutions for new problems? Well, you invent crap. And so those inventions lead to an abundance of new technology and math and science. And so we end up with the telescope, the microscope, the printing press, right? The Gutenberg Bibles being printed in the 16th century. We also have algebra and geometry and the decimal system. All of these things are invented during the scientific revolution. Now, inventing math, right? Like, who sits down and is like, this is calculus, like, here are all the rules, like, this is what we're gonna do. And it wasn't just one guy who was doing all of this. It's a collected, concerted effort that generally results in one guy taking credit for most of it. But just keeping that in mind when you hear these things. Okay. So the Middle Ages and the Renaissance scholars were looking for answers about the world around them from religion, right? We talked about that. We said when they can't find the answer or they don't know the answer, they just blame God, where they say, well, that's what is happening because of religion. That's the old view. Aristotle developed the geocentric model. So Aristotle was the guy that came up with this. Okay, this is Aristotle's kind of guide. And you can see it's all written in Latin. And so then scholars, humanists begin to challenge those authorities starting in the 1500s. So they begin to say, like, hey, I don't know if Aristotle is right. Like, maybe we are moving, maybe the sun is in the middle, like, I don't know. And so they start to question very ingrained thought. And these people who are beginning to question the authority are oftentimes ostracized in their fields. They're claimed to be wrong, they're claimed to be crazy. And then 100 years later, they're actually right. So just keeping that in mind also is that it's very difficult to be part of a revolution like this. So we talked about individualism, right? If I go back a slide, it says Aristotle preferred the individual, or sorry, humanists preferred the individual through thought and empiricism. Now, empiricism is what? What do you think it is? What does it look like? There are no wrong answers. What do you think empiricism is? Yeah.
Something to do with personal opinion.
Okay, something to do with personal opinion. Not bad, not bad. Anyone else have a answer they want to venture? What is empiricism? John Locke was an empiricist. David Hume was an empiricist. George Berkeley was also an empiricist. Anyway, empiricism is the theory that all knowledge is derived from sense experience. So I can see it, I can touch it, I can feel it, I can smell it, I can taste it, right? Your five senses. And it's saying that all knowledge, like all of the information that we have about the world, is derived from that. And so, with that being said, the only way to have new knowledge or to like have new information is to experience it, is to actually see it or touch it or watch it, right? That's kind of hard to do if you're talking about religious miracles happening and things like that, right? Like it's kind of hard to say like I saw God versus I saw the kite fly and I think it was because of the wind, right? Does that make sense? So these new ideas of thinking are challenging religious ideas because empiricism innately says you gotta see it to have it be true, okay? And so then we end up with science. They're like, well, I think this is true, so I'm going to do this experiment to test if this is true. So like if I'm Isaac Newton, right, years later, and I take this apple and I drop it to the ground, like what's causing that? Like why is the apple falling to the ground? Like why am I standing on the earth? Like gravity. So then you get a hypothesis and you test it and you see if it's right. And then finally, the pre-modern view, the old view, the Middle Ages and Renaissance view was very, very religious. And it just kind of accepted the church and religion as the authority for everything. Things weren't challenged. If they were told something was the way it was because it was the way it was, they just accepted that and said, okay, nothing I can do about that. Now we've got people challenging it. We've got people saying, I don't think Aristotle was right. Like, show me your experiments because I think I'm right and I think you're wrong. And we've got many, many, many new ideas. So we've got new lands, we've got new people, we have new food, new animals. Like, in what world did the Indians in the plains of Nevada think they would ever see a horse, right? We are coming together as kind of a global family during this time, like a global family that is committing genocide on native populations, but we'll get to that later. The age of exploration and scientific revolution are innately linked. So just keeping that in mind. Okay, any questions so far? All right. So talking about kind of pre-scientific revolution, pre-1500s view on science, magic, philosophy, and religion, Aristotle and Ptolemy were very into this idea that the Earth was at the center of everything. The Earth is at the center of the universe, and that's called geocentric. And then the church also was like, yeah, we like that view. We like humans being at the center of everything and the Earth also being there. So we're going to take that. And then we also have astrology, meaning, you know, when you're born and how the stars line up and the planets line up affects how you exist as a person. And alchemy is like chemistry. And so through those two things, people were really into thinking about magic in kind of a conventional sense and having that be true. Medieval philosophy had a focus on rediscovery of religious texts with non-religious learning. And part of this is because they're coming out of the Dark Ages, they're coming out of the Black Plague, and people kind of needed religion to keep them occupied and hopeful for some sort of nice future. In the Renaissance philosophy, there's a very strong focus on Aristotle and Ptolemy, and yes, the individual, but like the collective individual. Religion was not scientific and focused on unity. During this time, it was very much a divided kind of topic, even between different churches within the same region. So this is the Ptolemaic system, and we saw this before. There is the idea that the Earth is in the middle and everything else surrounds it. Aristotle comes up with it in the 4th century, so that's like 300 BC. And then Ptolemy then expands on it and kind of makes it a little bit better. I've kind of gone over all of this, so we're just going to move on. Does anyone have any questions about the geocentric model? Okay. So that's what the scientific revolution was all about. It was all about thinking about new ways of thinking and technological developments. What is the human role in the world and the universe? And what explains kind of the situations and things that are happening? And how do we have successful experiments, right? We try them out, we change, we have new technology. Let's build some stuff and see if it works. And so advances in math and in technology and in science allowed these scientists and observers to show these abstract theories that they're like, I think that if I fold this paper into a triangle and throw it, it's gonna fly, right? Like, that's kind of an abstract theory. But if you do it and you show it and you can see it, you're like, okay, yeah, that makes sense, right? So we've got this empiricism, this need to see, touch, smell, feel, or taste for it to be true. So, yeah, Michael.
Was like this type of like breakthrough thoughts like was it encouraged by like a ruler or the government, or
No,
was it just like just random?
it was just random, and it was also kind of highly discouraged because a lot of like rulers at this time were very religious, right? And so they don't want anything to contradict their religion and or their own authority. And up until this point, they had the authority to say like, that's right, that's wrong, because we're just telling you that.
Yeah.
Where now it's like, no, this is wrong because I can prove to you that it's wrong. And so it actually undermines their authority, which makes rulers not super happy.
So like there were very few like inventors, I guess.
No, and that's also not necessarily true, right? We get, and that's why these things are happening in countries where the leaders are generally more laissez-faire. So I don't know if you guys aren't familiar with what laissez-faire means. It just means like a hands-off approach to governing. So like England or Portugal or Spain or Italy, those countries, yes, had rulers, but they weren't like dictator rulers who were going to hang you if you came up with like new science ideas. And eventually these rulers begin to see why the inventors are correct, right? They're like, oh yeah, like we're wrong, like you are right, and this is helpful for us because now we can explore and have more money and whatever. So it's a net benefit for rulers, but at the beginning they were super hesitant.
Okay.
Yeah, good question. Anyone else have any questions? Okay. So some of the two kind of biggest breakthroughs of the scientific revolution is new discoveries and knowledge about the universe and about people, the human body. So astronomical, meaning astronomy, discoveries led to new ways of thinking about the universe. And then in addition to that, we have advanced medical knowledge, because a lot of the explorers were like, well, not explorers, scientists were like, well, what's the easiest thing for me to like learn more about would be like myself. So we kind of have this like individual mindset, and we have this like very broad, where do we fit into the universe mindset? And with that, alchemy turns into chemistry as well. So the Ptolemaic system was the geocentric model that Aristotle developed. We already talked about this. I'm not going to make you tell me what it is. We're not going to do that. So we then get the heliocentric theory, and this is Copernicus. So Nicholas Copernicus. And in 1543, Mr. Copernicus writes on the revolutions of the heavenly bodies. Now, this sounds like a super religious text, right? On the revolutions of the heavenly bodies. What in the world is Copernicus talking about? Well, having no other explanation or definition of what to call the floating things in the sky, he calls them heavenly bodies. So he's like, alrighty, these glowy floaty things in the sky, we're gonna just call them heavenly bodies because I'm not really sure what they are. But revolutions meaning how they revolute, right? How they kind of circumvent the world. Okay. So he says, Earth and planets revolve around the sun. We have a circular orbit. And he gets a ton of heat for this. People are like, you are so wrong. If the Earth was moving, we would know it. Like, what are you on? And he waits until he's almost dead to publish this. So he publishes this like days before he dies. Why do you think he waited? Michael?
I think, wasn't this like kind of common because a lot of inventors were like scared that they would be punished for
Yeah.
what they published, so like they knew they were gonna die soon, so they published it and they didn't get the criticism.
Yeah, right? He's like, well, this sounds like a personal problem for all of you to handle after I'm gone. So he publishes this super controversial piece and then dips, right? He's like, here you go, have fun, do this what you want, and then he dies. So that's kind of common in the scientific community, even today, I would argue, to have very strong opinions about something and publish them very late in life to ensure that you have a successful career and that you have money and you have a job and you have some friends. And then at the point where it doesn't really matter anymore, you can kind of publish the stuff that might get you in trouble. So that's what Copernicus does. He says, well, I'm pretty sure I'm right, but I'm going to just wait until I'm almost dead so I don't have to handle it. And we'll just let everyone else deal with it. Hannah.
Why do they want to die when, like, if they die, then like no one will know who published it and no one knows who's the founder of this, and like he won't get any credits for that. No one will know him.
So that's a good question. At this time, it's much less about give me the credit and much more about don't kill me for my thinking this. And so he's gonna wait until he's almost dead, right? He publishes it as himself, knowing that people won't believe him and knowing that he's probably going to have a lot of criticism on behalf of the church and on behalf of the scientific community and also whatever ruler is kind of in existence at this time. And so he waits until he's almost dead and he says, alrighty, the time has come for me to publish this super controversial piece of writing, change the way you view the world. But I'm going to do it right before I die, so you can't come imprison me for my views, A, and B, so I don't have to listen to you tell me how wrong I am. Does that make sense? Okay. Yeah, see, he feared ridicule from scholars and he was scared he was going to be like excommunicated from the Catholic Church. Also, he's still Catholic. Like, he still wants to go to heaven. And if he's excommunicated, then that becomes a lot more difficult. So he's going to wait until he's almost sure he's gotten in. He's fine. Like, they're not going to excommunicate him 3 days before he's dead. Like, he'll be fine. That's another kind of part of that. Okay. Up next, we have Kepler. Johannes Kepler and Kepler's first law. He's also talking about the universe. And now we are moving away from calling them, what was the terminology? Heavenly bodies to planets. We have laws of planetary motion. And this is published in 1609, so more than 50 years later. And these are Kepler's laws describing orbital motion. He basically wants to build upon Copernicus's heliocentric model. He wants to say, okay, these are the laws that govern the planets, and here's how they operate. He says the orbit of every planet is in an ellipse. So it's not a circle, it's an ellipse with the sun at one of the two foci. But he gets it a little wrong because he puts the sun at one end. So instead of putting the sun in the middle, he puts the sun like super far to the left. Galileo and the starry messenger. So anytime you see kind of the italic letters, that just means that he like published a word named this. So by the early 1600s, right, we've got Copernicus's model, we've got Kepler's first law, and now we've got Galileo. And scientists could explain the universe, but what they can't explain is what the heck the other planets are made out of and why the planets are moving. Like, why are we floating through space? That's kind of confusing to conceptualize. And so Galileo Galilei, father of modern observational astronomy, and also the father of modern physics, and also the father of science, also the father of modern science. This guy did a lot. He publishes 3 discoveries in the Starry Messenger. And these 3 discoveries are the fact that Jupiter has moons, 4 of them. The sun has dark spots, and the Earth's moon is not just this perfect little sphere floating through the sky. It's actually rough and uneven. And these heavenly objects were actually material. Like they actually are tangible and they exist. They're not just balls of floating light. They're planets. They have mass. There's something there. And that discovery is mind-blowing, right? Like, imagine you're just like in your small farm in the English countryside and it's 1600 and you're milking your goat and you somehow just realize that A, the world is moving, and B, the little floaty balls of light in the sky are actually humongous planets just like yours, orbiting around a sun, which is a burning ball of gas. Like, that information seems super sketchy for people that have no idea what mass is in general, right? Like, or what gravity is, or what any of this is. And so these ideas are super, super complicated for people to kind of understand. But Galileo does a good job of trying to explain it. Now, Galileo has some issues with the Catholic Church. Well, Catholic Church has some issues with Galileo. And here are some of the passages as to why. So in one of the passages from the Bible, it says, "Fear before him all the earth, the world also shall be stable, that it be not moved." Well, that kind of contradicts the fact that the earth is plummeting around space super fast and also spinning at the same time. And that statement would actually support a geocentric model, right? Where everything revolves around the world. And so all of these things are saying, like the first 3 are kind of against the heliocentric model. And then the last one is saying the sun goes up and comes down in the same spot, but Galileo's like, no, it doesn't. The sun comes up over there and goes down over there. So y'all are just wrong. And so is your Bible, right? He's being kind of accusatory, if you will. And so the Catholic Church tells Galileo he has to abandon his ideas or be excommunicated. Why? I gave you the answer already, but why? Why would the Catholic Church care? Like, it's one random dude who's talking crazy about floating balls of dirt in the sky. Michael.
Because it went against like what the Catholic Church said.
Yeah, exactly. Hannah, did you want to add anything?
I was gonna say like the Catholic Church dislike his ideas.
Yeah, the Catholic Church was like, homie, this is totally against everything we just talked about. Like, get on board or get out, basically. And so his discoveries were threatening the biblical concept of the universe. Keeping in mind that the biblical concept of the universe was written like 1,000 some odd years before this. Like, no wonder he's challenging these ideas, probably because these people didn't know what's going on. Okay. And now we get a fun conflict between faith and religion and science. And Galileo argues that the church should just reevaluate their truths, right? Be like, well, homie, if that's wrong, it's wrong. Just relook at it and fix how you think about religion. So he says, I hold the sun to be situated motionless in the center of the revolution of celestial orbs or planets, while the earth revolves around the sun. These men, or the people that are telling him that he's wrong, have resolved to fabricate a shield for their mistakes or their fallacies out of the authority of the Bible. These they apply with little judgment to the refutation or disprovement of arguments that they do not understand and have not even listened to. Before a physical proposition is commended, it must be shown to be false. He says, before you tell me that I need to stop talking about this, you got to prove to me that I'm wrong. So Galileo challenges the Catholic Church to prove to him that the earth is unmoving at the center of the universe. Now, obviously, they can't do that because it's not true. And so up until the middle of the 1600s, scientists have been able to answer the following questions: what the universe looks like, how the universe works, and what stuff in the universe is made of. So the guy that talks about what the universe looks like, the very first one is going to be Copernicus, and he develops the heliocentric model of the universe. How this universe moves is going to be Kepler, and he talks about the ellipses, right? The orbital ellipses. And what stuff in the universe is made of is Galileo, and he says it's actually made of something. They're not just like floating balls of light. And also, the Catholic Church can shove it unless they can show me that I'm wrong. Okay, so those are our three main guys for the universe at the start of the scientific revolution. And then we get Isaac Newton. My man, Isaac Newton, comes after Copernicus, Kepler, and Galileo, and he just rebuilds the universe. He's like, you guys did some awesome work. I really like it. I think you're right, and I'm going to just make it bigger and better. And so he teaches that the scientific theory, right? Scientific theory meaning like the process at which you do science should be coupled with experiments. So he creates science, basically. And then he also develops the laws of motion, the universal law of gravity, and all of this is published in Mathematical Principles of Natural Philosophy. So he's saying, I did all this research and experiments and work on math in the real world and came up with these conclusions. And through this, he describes how the universe functions. Like how is it like together? Like how are we here? Like how are we orbiting? What's going on? And he comes up with the universal law of gravitation. And he says every object in the universe attracts every other object by a force called gravity. The bigger the object, then the more gravity, right? And if an object is closer to a big object, then it has a greater gravitational pull. And this makes possible all of the other theories, right? This explains why the sun, as the largest mass, isn't moving and everything moves around it. Why do you think this theory was important to scientists in the 17th century? That's going to be the 1600s. Yeah.
Is it because they all thought like the sun, everything revolved around the Earth? So
Yeah.
So like this kind of went against it because the sun is more massive than the Earth.
Yeah, exactly. Exactly. Anyone else want to contribute? Okay. If mathematically proven, then this theory of gravity would explain all of the motion in the entire universe, right? It would explain why if I drop a pencil, it hits the floor. It would explain why the moon doesn't just float away. It would explain why Jupiter can have multiple moons and they all kind of stay within the radius of the gravitational field of Jupiter. So all of these things that were unexplainable now become explainable. So now that scientists understand the universe a little bit better, they start tackling other problems, like the human body. So Galen, who is a Greek physician and surgeon, super early surgeon and physician, made very early contributions to how we understand anatomy and physiology and neurology. But mainly just focused on like dissecting animals rather than humans. Now that can be super problematic for understanding humans because humans don't look like animals. And so he kind of has these ideas based on the work that he's done with animals, and he's just applying them to humans, which is problematic. William Harvey, a 1600s scientist, publishes the work on the motion of the heart and the blood. This is going to be like your circulatory system. And he's saying, okay, the heart is like the pump to circulate blood throughout your body. And he does this by looking at people's veins and seeing where things are going. So Francis Bacon is another big one. And his main idea is that scientists came to believe that reason is the main source of all knowledge. We talked about this, right? We're saying, okay, well, if you can prove it to me, empiricism, if I can see it with my own eyes, it must be true. Reason is the capacity to make sense of things, to say, alrighty, like if the kite flies and it's not magic and it's not God, then there must be something else happening. Maybe it's wind, right? This like that would make sense. That would be reason. And so this new kind of concept of reasoning, coupled with empiricism, those things kind of go hand in hand, is a new capacity for people thinking about the world around them and establishing and verifying facts, and or even just changing or justifying practices and institutions and beliefs based on new information. And I think this is still Francis Bacon, yeah. So the scientific method. Now this is the step-by-step guide to doing science. So he kind of creates an instruction manual for how to become your own scientist. And the scientific method is used even today in science classrooms. I'm sure you've all maybe learned about this a little bit. And it uses this belief of inductive reasoning. Inductive reasoning just means that you make an assumption and you test it, right? I think that if I push this cart down a hill, it will eventually stop. But it will eventually stop because, right, like friction, or because it hit something. Not because, I don't know, gravity stops, right? So this like idea of having a hypothesis, testing the hypothesis, reframing the hypothesis and testing it again, all comes from Francis Bacon. Inductive reasoning is getting rid of any past conceptions you might have about how the world works. So just getting rid of anything you thought you knew, and then going into it with a fresh mind with all of the facts that you know and all of the things that you don't know and want to know. And then underlying that is your process, right? You just come up with the ways in which you're going to test your hypotheses. Inductive reasoning drives the scientific revolution. Everyone is about inductive reasoning. Bacon wanted science to advance human life with new discoveries because he knew that science could benefit everything. It could benefit people and the economy and trade and agriculture and industry and education, right? And all of these things coupled together. Here's the scientific method discovered and created by Francis Bacon. Identify a problem or question, form a hypothesis, do your experiments, record what you did, and then analyze it and come to a conclusion. Science often proceeds by a process of successive approximation. That means you gotta just guess, right? We often have ideas about the world that we think are true. So make that assumption. See how it fits into reality. Modify it or trash it if you have to. Try again. Keep trying until you are relatively successful. And that's kind of the entire thinking of the entire scientific revolution. Like, oh, I think this is right. I'm gonna do this to test it. Oh, actually, I'm super wrong. So let's trash that idea and try a new one. And so that's kind of the basis of the scientific revolution. Alrighty, I've done a lot of chatting. Does anyone have any questions for me right now? So what we're gonna do is we're gonna do a little brain break and watch a video. And then you're gonna break out into breakout rooms for the last couple of minutes of today's class and fill out a worksheet on the people of the scientific revolution. It should just be review. If you want to use Google, you can. And then you'll just present those, or if post them, there'll be a homework sheet. So just post those as homework if you don't finish them before next class. Does anyone have any questions? How many of you have access to the Google Classroom right now? No, okay. You'll get access this week. If for some reason you don't have access before next week's class, that's fine. Like just complete the worksheet and then you can post it when you get access, okay? All right, let's watch this.
Jackson. I'm from Ireland. What I did for my Rise project was reimagining ancient Irish myths.
Hi, I'm John Green, and this is history. Okay, so look, it's been bleak so far. We've had the Black Death, the 116 Years' War, a series of religious wars that culminated with a 30 Years' War that killed 20% of Central Europe. We've had the Little Ice Age and witch-murdering mania and the Atlantic slave trade. But now we get to turn our attention to the scientific revolution, which profoundly reshaped our understanding of the universe and ourselves. At last, we are going to make real, undeniable progress. What's that? Oh, Stan tells me that many of these scientists were persecuted for sciencing. Great. But that doesn't stop humans from developing the central insight that reshapes human history. It's about to get really heliocentric around here. Before we get into the scientific revolution, I just want to make one broad comment that might be obvious if you've watched previous videos in this series. For most of human history, people did not expect to live healthier or more prosperous lives than previous generations. Sometimes life got better, and sometimes it got worse. It's true that human populations were increasing and that life expectancy was increasing gradually, but the idea that it is normal for human life to get better over time is very new. Today, most European countries have high life expectancy, low maternal mortality, and low rates of absolute poverty. But there have been about 10,000 generations of humans, and we are perhaps the 10th generation who could reliably expect disease burden and child mortality and poverty to steadily decrease in our lifetimes. Well, I'm part of the 10th, you're probably part of the 11th, but regardless, we owe much of this change to the scientific revolution. So like the Reformation, the scientific revolution was another break with religious teachings. The Catholic Church taught that the Earth was the center of the universe and had been so since the creation. The sun, moon, and planets traveled around the Earth in perfectly circular orbits like the rings of an onion. And beyond the onion was the realm of the divine, whose light pierced through in the form of stars. All this perfect motion was the work of God himself, and any other understanding of the universe was therefore a challenge to God's eternal perfection as described in the scriptures. But like good Renaissance people, the new astronomers and mathematicians and their colleagues in other fields declared that these old theories needed to be re-examined. The first problem was that the perfect orbits of the planets and moon and sun did not fit with observation, causing astronomers to resort to ancient Ptolemaic explanations, basically that the planets followed their own circular paths, which also revolved around the Earth. Anyway, just before his death in 1543, Polish-born Nicholas Copernicus, a well-connected doctor of canon law and a researcher in mathematics and astronomy and classical literature, published On the Revolution of the Celestial Spheres. He noted problems with classical astronomical theory and determined that the universe was heliocentric, that is, the sun rather than the Earth was at the center. The Catholic Church's reaction to this was negative. The Italian monk Giordano Bruno, for instance, was burned at the stake in 1600 for teaching Copernicus's heliocentric findings. But even earlier than that, in 1572, Danish astronomer Tycho Brahe spotted a new star, and in 1577, a new comet, further confirmation that the universe was not immutably and perfectly created. Then Johannes Kepler's laws of planetary motion announced early in the 17th century that the orbits of the planets were elliptical, not perfectly circular. The solar system was a solar system, and it wasn't an onion. Something other than divine will was keeping the planets apart and in motion. Let's go to the thought bubble. By this time, the observations of Galileo Galilei were bringing matters to a head. Galileo was obsessed with science, especially its mathematical features and the calculations at the base of Copernicus's heliocentric theory. Galileo's father had wanted him to become a doctor, but mathematics drew him in. It's the oldest story in the world. He invented many tools like an early thermometer and his own telescope, which he used to dramatically improve human understanding of the universe. He was the first person to observe the moons of Jupiter and the first to understand that the Milky Way was a collection of stars. The telescope also showed irregular spots on the sun, a further sign of heavenly imperfections that went against the beliefs espoused by the Catholic Church. Despite Galileo's prestige as a mathematician, his work on the nature of the universe went too far for the church. In 1615, Galileo went to Rome to teach the clergy about the heliocentric universe and convince them of its accuracy. In 1616, it was condemned as heretical, and Galileo promised not to teach that the Earth moved. But in 1632, he published Dialogue Concerning the Two Chief World Systems, in which he described the Ptolemaic system, on which the church based its Earth-centered astronomical teachings, and the Copernican system. In 1636, the Roman Inquisition found him guilty of heresy and forced him to recant in order to avoid execution, and so Galileo recanted. In 1992, after a 13-year investigation, the Catholic Church finally publicly acknowledged that the judgment against him had been wrong. Thanks, Thought Bubble. Centuries later, Albert Einstein would write, "All knowledge of reality starts from experience and ends in it." Because Galileo saw this, and particularly because he drummed it into the scientific world, he is the father of modern physics, indeed, of modern science altogether. We talk about this at length, of course, in our History of Science series, but for our purposes here, it's important to understand that Galileo and other scientists used experimentation and mathematical calculation to confirm or refute hypotheses, and that scientific method was genuinely revolutionary. The scientific approach also spread to other fields of inquiry. Ancient medical theories began to unravel as English medical doctor William Harvey pronounced the heart to be a pump based on dissections he performed. He called the heart a piece of machinery that worked according to natural laws. But it's important to note that even as these mechanical theories took hold, prominent new scientists continued to believe in unseen forces at work in the universe. For example, astrology, positing that the planets and stars influenced people and events, sought to map those influences, and some scientists found that quite credible, and they pursued all kinds of other mystical and occult and alchemical investigations. Any revolution needs good propagandists, and people were advertising that the new scientific values and practices were amazing, while also pointing out that the ancient and traditional ones were full of errors. English politician Francis Bacon was foremost among these science propagandists, chiding everyone who was using the old paradigms and models of the universe, calling them worthless ancients. Bacon, like others at the time, created his own careful observations and experiments and sought to use reason. There was, he said, a scientific method to be followed. One needn't rely on past accounts that were copies of copies of copies. One should ask their own questions and do their own experiments to find the answer to those questions, experiments that other people could then replicate to confirm or refute the findings. And this became the basis for the new scientific method as Bacon laid it out in The Advancement of Learning. His process of reaching the truth and drawing conclusions from specific, reliable facts or evidence is called inductive reasoning. And a collection of reliable, verified evidence was essential, according to Bacon, not old wives' fables, or as another new scientist put it, not maunderings of a babbling hag, words that were part of the discourse of witches who were being tried and murdered at the time. And then there was French philosopher René Descartes, who moved speculation about this new science to a still different methodological register by looking at the mind. Descartes noted that reason, thinking, was made for verification, so thinking on one's own was crucial, because otherwise there were so many facts that one could essentially become skeptical about whether truth really existed. Like, imagine a world where there are facts, but there are also alternate facts, and you have to choose between your set of facts before you reach a conclusion. That would be unlivable. So Descartes set out to prove the one thing that he felt he could be sure of, his own existence. And in doing so, he prioritized his own power of thinking, famously writing, "I think, therefore I am." But he also prioritized doubt, which is central to the scientific method. Descartes also wrote, "We cannot doubt of our existence while we doubt." In short, our ability to conceive of doubt about whether we exist is proof that we exist. By privileging the role that thought, and with it questioning, play in discovering truth, Descartes had developed deductive reasoning, that is, faith in the rational power of the mind to generate specific truths from its own theories or power of thinking. By the way, in addition to our crash course on the history of science, we also have one on philosophy where you can learn more about Descartes. Okay, let's turn our attention to Isaac Newton, who synthesized new methodology and his own findings in his universal laws of motion. Newton was a scientist with a reputation for following every lead, including many that went nowhere. For instance, he practiced alchemy, that is, the quest for secret formula and practices, especially an entity called the Philosopher's Stone that could turn lead or other base metals into gold, which, by the way, would be an inflationary disaster, but fortunately it's impossible. But I think it's important to note Newton's interest in alchemy because it reminds us that not every lead being followed by scientists, then or now, results in big discoveries, but part of the glory of science is learning what doesn't work. Also, it reminds us that in the 17th century, many of the smartest people in the world believed in alchemy, a nice opportunity to reflect on what false promises contemporary humans might believe. At any rate, while studying alchemy, he also pulled together the findings of his predecessors into mathematical laws for the functioning of the universe. He quantified the major constructs of mass, inertia, force, velocity, and acceleration, and produced the law of gravitation. And he encapsulated all his findings in his Principia Mathematica in 1687. For Newton, the universe was indeed a fantastic, regular, and all-encompassing machine, yet it was a machine still tinged with the mysteries that he continued to decipher, and to be fair, that we are still deciphering today. By the early decades of the 17th century, contact with the wider world led to other kinds of scientific investigations. Adventurers brought back to Europe new species of plants and textiles, minerals, animal life that sparked wonder and scientific probing. One of the first to venture out was Portuguese Dr. Garcia da Horta. He traveled first to Goa, India, studying plants like aloe and cannabis and coconut and ginger. In 1563, he published Conversations on the Simples, Drugs, and Medicinal Substances of India, which advanced the use of plants as medicine. Local people were key to major plant discoveries. Dr. da Horta, for instance, learned from healers in South Asia, while in the 1620s, local people in Lima cured a Jesuit priest with malaria by giving him the medicine they used, quina. Eventually, this healing bark was turned into quinine, a malaria medication that allowed Europeans to expand their empires more deeply into Africa and South America. In the cases of both Dr. da Horta and the Jesuits in Peru, European advances, like others that would follow, depended on gathering up scientific and medical knowledge from other people. Within Europe, scientific networks developed around heliocentrism and also around other new ideas, just as they had in the Renaissance. Like Erasmus and his correspondents, Galileo and scientists across Europe wrote one another and published books about their findings. The Royal Society of London had its so-called Republic of Letters, and communication like that became pivotal both to verification and to convince as much of the public as possible that these new scientific discoveries were valid. Amid warfare and the Little Ice Age and famine, these scientists were corresponding about comets and windmills and pumps and blood vessels. Theories about vision and atomism passed around in letters that reached as far as the Ottoman Empire and Japan. Governments also got in on the scientific revolution, giving scientists like Galileo stipends to support their work and labeling them court mathematicians, which added prestige both to the scientist and to the royal court itself. Louis XIV of France started one of the most prestigious scientific academies, the Royal Academy of Sciences, in 1666. And theaters of anatomy, where dissections and other physiological demonstrations occurred, also received official sponsorship. Oh, did the globe open at last? Is Yorick in there? Alas, poor Yorick. I didn't know eyebrows were a skeletal feature. For the first, 98% of history, we knew so little about how all of this works. Look, I'm never going to be a ventriloquist, okay? Stan, this isn't a real skull, is it? We'll examine the mounting power of the state next week beyond its sponsorship of science, but for the moment, let's reflect on the ways in which so-called new scientists during the 16th and 17th centuries bravely took religious scriptures out of the workings of astronomy and the heavens. Instead of a divine hand at work, by the time of Newton, universal laws for the operation of the solar system and physical bodies had been established. And although most people believed in God, many of them earnestly so, they also also followed a developing scientific method and additionally established faith in their own rational powers. This way of looking at the world would prove so important that less than 350 years after Galileo became the first person to observe the moon's cratered surface, human beings would step foot on that surface. Thanks for watching.
Okay, well, that actually brings us to the end of class today. So we'll do the activity as a review next time. So you're not gonna have homework, we'll just do it as a review next week to review the people of the scientific revolution. Does anyone have any final questions for me before we're done today? Alrighty, awesome job. It was nice to see you all, and I'll see you all next week. Bye now.
Bye.
Bye.
Thank you.
Thank you. Bye.
Bye.
Bye.